Hey there, algebra friends. Today we are going to be talking about 10.2.3. How can I solve it? Multiple methods for solving equations. So I love this series of lessons we're going to be doing this week. It's actually some of my favorite topics to teach because basically what we're going to be doing today and the later this week is we're going to talk about three different approaches, or you can even think of them as mindsets or strategies to solving equations. So you all know how to solve equations, right? If I tell you x plus 3 equals 5, you would probably subtract 3 from both sides and tell me x equals 2, which is excellent. But we're really going to break it down today and really think about, how can I solve an equation? There's not only one way to solve any equation. There's lots of different ways to think about it. And we're really just going to think about problem solving today. And I love that. We're just going to pause and take a look at an equation and think about, which strategy makes the most sense for this particular equation. So I kind of think that kind of mindset can apply to life as well and your real life problems and struggles. So I really love this lesson. So I'm excited to get started here. Before we do, I'd love to know from you folks your quarantine routine of what you guys are dressing up for while you're doing your schoolwork. Do you wear what you usually would wear to school, whatever that means to you? Or are you guys like dressing it up more or dressing down more, staying in your PJs? Are you ever just like, you know what, I'm just going to put on a cute outfit today just for fun, just to feel dressed up? I would say for me, I am most definitely going way comfy, mostly wearing jeans and t-shirts and not my usual little teacher outfits of slacks and whatnot. So I'm enjoying that aspect. So I'm curious to hear what you have to say. So with that, let's get started here. Our warm-up is this tricky looking equation here, the square root of x plus 5 plus 4 equals 20. So pause the video and really, without my voice kind of leading you, think what solving step would you do first? So how would you approach that problem? So pause this. There's no wrong answer here. Welcome back. Hopefully you paused it. And, whatever you wrote down for your strategy is not wrong. Even if it's a wrong step, that's okay. That's how you thought of the problem. That's fine. The big thing that we're going to get into today is there another way? So what I'm guessing most people kind of do when I ask them to solve an equation is they start subtracting 4. And I don't even know if anyone is thinking about why they're subtracting 4. It's just like mental, response, right? And then, is that wrong? No, that's a great solving step. But maybe other people thought, well, what number plus 4 gives me 20? What number plus 4 gives me 20? Well, that would be 16, right? 16 plus 4 equals 20. So just some different strategies, different thinking patterns, and we're really just going to put a name to each of these thinking patterns, and some you might love, some you might never use again, and that's okay. We're just going over some strategies today. So we will get back to that problem a little bit later today. Let's really talk about our 3 strategies, okay? So I've got the rewrite strategy. So rewrite the equation. Most often that's going to be with using the distributive property to get rid of the parentheses, okay? So in this equation here, that would mean distributing this 4 through, so 4 times x gives me 4x, 4 times 3 gives me 12, equals 20. So I'm going to rewrite this equation in a way that allows me to solve it maybe how you're more comfortable with solving it, right? Getting rid of those parentheses. And I get x equals 2. Okay, so our strategy was to rewrite it and then solve it through. So that's our first strategy. okay? Another strategy, and I kind of got into this in the warm-up today, is what it's called the look inside. Do you see me? I'm looking. And we're asking ourselves, what must this part equal to make the equation true? Okay, so I like to use my highlight tool for this. Don't even worry about x plus 3 right now, guys. 4 times what number gives me 20? So 4 times what number gives me 20? Well, 4 times 5 gives me 20. Alrighty? And so I'm looking inside the parentheses and I'm asking myself, what does that have to equal? It has to equal 5, right? This in parentheses has to equal 5. So I can jump right to this step that x plus 3 has to equal 5, since 4 times 5 equals 20, and I can get the same answer, x equals 2. So that's the second strategy. It's called the look inside. This one, our last strategy here, our third strategy, is the undo it. And so I think we've seen this one before. Think opposite. So what you're doing is you're undoing the last operation that was done to the variable. Think opposite. So opposite of multiplication is division. Opposite of addition is subtraction. Opposite of squaring a number is square rooting a number. So just a couple opposites that you might see. I would maybe circle them, take note of that. Those are probably the ones you'll most frequently be seeing today, and go so on. Sorry, guys, I forgot to erase my ink from the last lesson here. Okay, so scroll up. So to undo it, I think that's a Carrie Underwood song. Anyone know that song? We are going to undo what's on the outside, or the last operation. So to undo a multiplying by 4, I would divide both sides by 4, right? So I'm undoing that. This is something we did last week, right? With getting fraction busters to get rid of those denominators. So I'm undoing that multiplying by 4, so that cancels out. That's the purpose of an undo. 20 divided by 4 gives me 5, and I get x equals 2, right? So those are the 3 different approaches or strategies that we're going to be practicing. And you know what? Some strategies make more sense with certain types of equations. Some strategies work better for some math learners, and that's all good. That's all fine. These are just different problem-solving strategies. So with that, let's kind of try each of these 3 again. So our first strategy is the rewrite. So can you frame the problem differently? Can you make it look a little different so that it's a little bit easier to solve? So what I did is I distributed that 5 through, and then I solved like I'm used to solving, right? So I get x equals 4. All right, so that's the rewrite. The look inside is asking yourself, what does this in parentheses have to equal? 5 times what number equals 15? That highlighted quantity has to equal 3, because 5 times 3 equals 15. And solving this, I get x equals 4. So even just like those 2 strategies alone, folks, do you see the process looks different, but the answer is the same? And so I just think that's really kind of neat for us to really, we talk about this all year. Different strategies are great, but to see it really next to each other, I think really helps you realize there's a lot of different ways to get to the solution, and they're all great. All right, so the last one here is the undo. So I'm going to undo the multiplication by 5 by dividing by 5. So I get x minus 1 equals 3. And so again, I would get x equals 4. So kind of cool here. You can use multiple strategies to check your answer. All good stuff here. So let's do these last row of problems using each of the strategies, and then you can get started on your homework, your little review preview. What is homework? We're doing all of our work at home. Sorry. We're just learning. We're just doing math, okay? So to rewrite this, so x minus 7 quantity squared equals 9. In order to rewrite this, folks, I would have to multiply x minus 7 squared out, right? Squared means I multiply it by itself. And so I would get x minus 7 times x minus 7. And this is a little blast from the past. We haven't done these problems in a while. X times x is x squared. X times negative 7 is negative 7x. And negative 7 times negative 7 is 49. Which of these are like terms? The negative 7s. So I get x squared minus 14x plus 49 equals 9. Well, now this just turned into a quadratic problem that we've been doing, right? So we need to set this equal to 0 because it's a quadratic. And now I can either factor and use the zero product property. I can use the quad formula. I also could just type it into Desmos and look for the x-intercepts. So I'm actually going to try factoring this. I've just been really enjoying factoring lately. And I'm already kind of thinking, ooh, 40 and 14, that kind of already I'm thinking, hey, 10 and 4, right? 10 and 4 make 40, 10 and 4 make negative 14 if I'm adding them. But in order to multiply to a positive and add to a negative, they're both going to have to be negative, right? And again, if you're not as quick with your factors, just Google your factor chart. You can still get there. And so this is going to factor to be negative 10 divided by 1. That's just negative 10. Negative 4 divided by 1. That's just negative 4. So those are my two kind of magic numbers. And now I just use the zero product property to set them both equal to 0. Right? And we've been talking about how it ends up always just being the opposite. So this was a negative 10 over here, and my answer is a positive 10. That was a negative 4 over there, and the answer is a positive 4. So those are my two final answers. I'll kind of circle them in two colors. So my two answers there are 10 and 4. 10 or 4. Those are my two solutions. So that was quite a bit of work, right? So maybe some of you are thinking, I don't think I'm going to be rewriting when I do that problem, which is okay, right? Not all strategies work for all problems. So the second strategy is the look inside. The look inside. I love using the look inside for these types of problems. I think it just makes more sense to me to think about what number squared gives me 9. What number squared gives me 9? So to get a positive 9, I can either do 3 times 3, or I can do negative 3 times negative 3. So that means x minus 7 either has to equal 3 or it has to equal negative 3. Alrighty, and now I can just solve each of these little baby equations, and what do you know? I get 10 or I get a positive 4. So looking at those two problems alone, the work is starting to look very, very different. They both got me to the same answer, but the process looks very different. So depending on what kind of mathematician you are, one process might work better for you, and that's okay. Let's try our last strategy is the undo it. Okay, so this squared, what's the opposite of squaring? Remember we talked about that up there. That's going to be the square root is the opposite. So the square and the square root cancel out, and I get x minus 7 equals 3. And what do you know? Solving that, I get x equals 10. Now, the tricky part with this undo is the square root of 9 is 3, but we also have to remind ourselves if I'm squaring